Okay, good afternoon, students. Shall we start? So, shall we start? Yes. Okay. So, we will discuss the new topic, which is the analysis of trust. Okay. So, this is the new topic. So, what exactly is trust? It is actually a structure which is composed of different members. Those are joined together in such a way that these members will resist the change in the shape, or it will try to resist the relative motion of the members which are connecting or which are making that complete structure, right? So what comes in your mind, which type of structure is possibly can resist the change in the shape of that complete structure as a whole or the members? So necessarily, if I consider a structure which is made up of three members, okay, and certainly the three members will form a triangular shape. Such kind of structures, if you analyze or if you try to see the load which it can carry, and based on that load carrying, you will see it will try to resist the relative motion of the members because of which it is made up of, by which it is made up of. For example, let's say a force is acting on this triangular shape in this manner, and what I will do, I will make these two joints, one hinge, another roller support. Okay, for time being, that is joint A and joint C, they are hinged and roller. That means you will expect that there is no movement, but there is no translation at these locations. Now, what will happen if a force P is applied at this point B? There is no change in the shape as such. This force will be resisted by this member, and it will also be resisted by this member. So there is no relative motion of these members. So such kind of uh, structures which will try to resist the shape, they are known as trusses. Okay. So as far as truss is concerned, in order to make the structure rigid, the members of these structures or these trusses should be joined together in such a way that it will prevent any kind of movement between them. So that's what I was discussing about. There should not be any kind of relative motion between any of the bodies or any of the members. That is nothing but what we are doing. We are trying to make the structure rigid. Rigid in the sense it will not move, isn't it? So such kind of structures are known as trusses. There are other forms of structures. For example, if I say if there are four members, let me say these four members are forming a structure, something like this. And again, what I will do, I will connect these two locations with the help of a hinge and a roller. Okay. I will tell you the significance why I have considered one hinge and one roller support. But for this time being, you understand, if let's say such kind of loading is provided on this structure, what do you think will happen? Let me say member AB, BC and CD. What do you think? will be the change in member BC, member AB, member CD, and member AD. So do you expect any kind of movement with respect to this load in member BC, AB, AD and CD? Yes. Do you expect any kind of movement? So what I can do is, since it is an inclined force, I can resolve this into components. And over here you will observe that this horizontal component of the force, it will try to displace this BC. And as you can see, there is no such restriction which is offered for the movement of this member BC, right? And what will happen? There will be certain amount of deflection or relative movement as far as member BC, member AB, and member CD they are concerned. Okay, so this process, this structure is not a rigid structure, right? And it is known as mechanism, wherein you will find relative movement of the members by the virtue of the external force. But if in this very structure, if I add one more member which is a diagonal member, what do you observe now? Even if I apply certain loading, what do you observe? That by the presence of this diagonal member, the relative motion of this member BA or AB is restricted. If it is restricted, naturally BC will not move and certainly CD won't move. So this is known as rigid structure. And since the shape is triangular, this is known as truss. Okay, so the mechanism is now converted into a rigid structure wherein there won't be any kind of relative motion of the members, relative motion between the members. Okay, then what if I add one more member which is diagonal member? Over here again, there won't be any kind of movement in any of the members by the presence of this. But because of that, what has happened? This has become over rigid. Okay. So the first stage, this is your mechanism. Okay. This is mechanism. Second stage, where one diagonal member was introduced. This is, you can say, a rigid structure, or since it is triangular shape, you can call it as truss. And in the third case, this is over rigid type of structure. This has now become over rigid, extra rigidity. Extra rigid type of structure is obtained. Okay, so these are different types of structures, and these are majorly the rigid, or you can say over rigid type of structures, and such kind of structures which where we observe relative motion of the members between the members. These are known as mechanism. We are interested in these members, or the truss structure as a whole. Okay, so we will be analyzing trusses. Before analyzing truss, now I will discuss about these points or these joints. Why I have considered one hinge and one roller support. Now just try to understand. Uh, See, whatever discussion we are doing, this is with respect to two dimension, that is x and y axis. Two dimensional analysis we are studying. Over here, see how many reactions do you observe at point A? There will be two reactions. and at this point D, there will be only one reaction. These are unknown forces. These are reaction forces which are developed at these supports. This is what we have learnt in our free body diagram concept. Okay, equal and opposite forces, they are developed. Now, how many equations of equilibrium do we have? We have three equations of equilibrium. Okay, with the help of these three equations, whatever are present, we can find out the equivalent number of unknown parameters. So how many unknowns are there? 1, 2, 3. So these three unknowns can be found out with the help of available equations of equilibrium, right? And therefore, in order to maintain that determinacy, we apply one hinge and another roller support. Had that been, let's say, hinge, if it was hinge, what you would have observed? 3 and 4 unknown reactions. So a additional, isn't it? Additional or redundant force will come into picture. That we don't want. We want to avoid that. Therefore, most of the time, you will see that the trusses, they have got one hinge and one roller support in order to make this structure determinate. Okay, so that the reactions, whatever reactions are developed at these supports, they can be easily evaluated. So that is the modification that has been introduced as far as trust is concerned. Okay, fine. So this is a background related to the different members of trusses and the support conditions. Now, for this truss, simple truss, wherein you will find that there are three members, A, B, C. That is member A, B, B, C, and AC. Okay, these are the three members. Let me call M to be number of, or rather not number of members. I will call them to be forces in member. How many members are there? A, B, B, C, and AC. So in this particular truss, there are total three numbers. Let me assume that by the virtue of some external force, some internal forces are developed. So why these internal forces are getting generated? Because in order to balance this external force, equal and opposite stresses or reactions or force, they will be developed in order to oppose this. Okay, you will find that all the members will contribute to the opposition, and therefore there will be some forces. These forces are in the form of axial forces. They may be compressive in nature, or they may carry tension force. Okay, so once I say that either or, that means these are unknown forces. Okay, so let me consider M to be the forces which are unknown forces. In the member. Okay, these are unknown forces in the member. In addition to these unknown forces, you will have these reaction forces which are again unknown. Okay, so these are unknown reaction forces. So let me call R to be the reaction forces at support. supports. So again, this is unknown parameter. Okay? Let me consider these joints. One assumption in trust is that all the members they are connected with the help of pin joint. Okay, so this is an assumption. Pin joints are provided in order to connect different members. So you know, for two-dimension case, that is 2D, in a pin, how many reactions do you observe? One vertical, another horizontal. Okay, so we know for a pin support there are two reactions. Okay, and these are known as joints. This is joint A, this is joint B, and this is joint C. So joint these points A, B, and C, they are known as joints. So let me consider J to be number of joints. So in total, what we can see, these are known values, isn't it? We know for a given truss, we can see how many number of joints are there. We can calculate easily, 1, 2, 3 for this case. And we know that for pin joints, there are two reactions for two-dimensional case. Two reactions will be developed. So in order to maintain equilibrium, the number of knowns should be equal to number of unknowns. What did I say? The known should be equal to unknown in order to maintain equilibrium. Then and only then the internal forces will be developed. So how many known values you have? This. So it is represented as 2 into j. If this 2 into j value is equal to summation of unknown, that is n plus r, then we say that this truss is rigid. This is rigid and it is determinate kind of truss. That means the unknown values can be easily found out if this equation is satisfied. We can verify this. We can verify this at this stage itself. For this truss, how many joints do we have? 1, 2, and 3. Okay, so the left hand side equation, what it becomes? 2 into 3, which is 6. On the right hand side, how many members do we have? Member forces or forces in the member? 1, 2, 3. These are unknown. Okay, so 3 plus how many unknown reactions do we have? 1, 2, 3. So this also comes out to be 6. Okay. This is one small example. One more example can be C. What I can do is, so this is a truss. I will add one more, member, or I will add one more joint, you can say. Okay, and this joint will be connected with the help of members. Fine. So now you please let me know how many joints do you find over here? Yes. Can you please tell me how many joints do you see over here? 4 number of joints. So I can say j equal to 4. 1, 2, 3, and 4 number of joints. How many reactions on pin supports do we have? That is 2. That is what we have written. So 2 times j will be 8. Okay, this is what we know. Now what are the unknowns? So How many member forces do we have or members do we have? 1, 2, 3, 4 and 5. Do you agree? There are 5 members in our case. Yes, total 5 number are there. Okay? So I will write m is equal to 5. Correct? How many reactions do you observe over here? Again, 3. So m plus r, how much it comes out to be? 8. So this again can be considered to be a determinate kind of truss. Have you understood this thing? Is this clear? So let me say if I add one more joint and I will not provide any kind of support over here. It is like that only. What do you observe in this case? Yes. Tell me. How many members do you observe? 7. 7. So 5, 6, 7. Correct. How many reactions? 3. 3. So n plus r equal to 10. What about 2 into j? How many joints? How many joints? 5. 1, 2, 3, 4, 5. So left hand side is equal to right hand side. Okay? So everything is rigid. There is no movement. There is no relative movement between any of the members. There is no mechanism as such. So this is true form of a truss. And remember, we are discussing everything with respect to the 2 dimension. If this was 3 dimension, then the what you can say the formulation it changes. It will change accordingly. But the concept remains the same. I hope you have understood this thing. Okay? So there are few assumptions which are to be followed whenever we analyze a truss. We call it as a simple truss. So there are few assumptions you can write down if you want or you can recall. First is the ends of the members are pin connected. The joints में जो बोल रहा था, the joints or the ends they are pin connected. Okay, this is first assumption. Second assumption is the loads they act only at the joints. This is very important assumption. Loads act only on the joints or at joints. That means you will never find in a truss such situation wherein the loads are actually acting on the member. If you find such thing, then you are supposed to convert this whatever uniformly distributed load or uniformly varying load, whatever may be given, you are supposed to convert and transfer the equivalent amount on the joints. Okay? So loads they are acting only at the joints. Third is self weight of the members. Negligible. Negligible. So weightless. And the cross section of all the members are uniform. Cross section of members uniform. These are a few assumptions, and based on these assumptions, you are supposed to analyze the truss. Okay? We have already seen we have already discussed that for any member, if the force is acting in this manner, which is trying to compress it, okay, what do you observe? That these forces which are developed internally, okay, they are your compressive force, isn't it? Or we call it as the compression. One thing to be remembered in this case, that these members will carry axial forces. Axial forces only. Axial forces का मतलब क्या होता है? The forces which are acting along the axis of the member, those are known as axial forces. So the axial forces majorly are tension and compression. Okay? So compressive force, the representation shall be like this, and reversed, if the forces are acting in the on the joints like this, which is trying to pull that member, so the internal forces which are developed along the axis, it shall be tension. So this will be the representation of the tension force and the compression force accordingly. Okay? So you can say for compression, it will be the forces which are pushing towards the joint force. If I consider this section, let's say I consider this section on the left hand side towards the joint, the force is acting, so that is compression, and for this is moving away from the joint, that will be tension. Okay. So to analyze a truss, there are two different methods, rather three methods, out of which two are analytical, one is graphical. So these three methods are method of joints, second is method of sections, and third one is the graphical method. Graphical, which we are not going to discuss. We will be discussing only method of joints and sections. So let us see what are the what is the process or procedure in order to analyze a truss with the help of method of joints. So let's say there is a truss which is given to you, and on this truss you will find the load which is acting, it is actually a point load, or point loads you can say, and they are acting on the joint as per our assumption. Okay. So let's say this is the truss, this is actually let's say hinge support, this is roller support. Over here there is some load which is of 60 kilonewton, then 40 kilonewton, then this is 50 kilonewton. Okay. And there are a few more informations as far as joint. Angle is given, this is 60 degree, this is 60 degree, 60, everything 60. This is 2 meter distance, 2 meter. You are supposed to analyze this truss. Analysis का मतलब है you are supposed to identify the unknown values. How many unknowns? So in this case, as per our discussion, we know that the member forces are the one which are unknown, in addition to the reaction forces. So first of all, see to it that whether this structure is externally determinate or not. Externally determinate का मतलब होता है whether the supports or the support reactions, whether the support reactions can be calculated with the help of available equations of equilibrium. So yes, it can be, because there are three unknowns. And there are three equations, available equations of equilibrium. That is summation of forces in x direction, summation of forces in y direction, and summation of moment about point equal to 0. So with the help of these three available equations, three unknowns can be easily found out. So externally it is determinate. We now need to check whether internally it is determinate or not. Meaning of it is whether this equation is satisfied or not. So can you please let me know how many number of joints do we observe over here? How many joints? J? Count them. 1, 2, 3, 4, and 5. How many member forces or members do we have? Can you please count and let me know? Yes? 7. How many reactions? 3. And yes, internally also, or this stress can be said to be rigid and it is determinate. I mean, the unknown forces can be determined. So this equation is satisfied. Now, before analyzing, where exactly have you witnessed such kind of process? Can anyone tell? Have you seen such kind of triangular members which are connected in order to carry some kind of load? Have you seen such kind of shapes in any structure? Yes? Come again? Shades, exactly, shades. Then railway bridge. Are you trying to say railway bridges? Right, right. Someone just said about the electric towers and all. So right. So all these structures, they are triangular. They have some triangular shaped members or small structures associated to them. They are there, and the reason is to carry huge amount of load, comparatively huge amount of load, and the member sizes, if you see, they are very small. Okay, so that is the strength of this shape. Okay, and you can expect certain type of loading. You see, whatever concentrated loads are given, you can expect these things, and for this uh, point loads, how they come actually, or how they are to be considered, that forms a different part of the study. Mostly you will find the wind forces, they are actually, acting on such kind of process, because you will find the shades or towers, they are elevated from the ground. That means the height of these structures are quite long, or they are quite high, isn't it, from the ground surface. So one more thing is that if you move above the ground, the air pressure it increases, and the pressure is exponential, it will increase exponentially. At these locations you will find there will be certain amount of wind load, and these wind load calculations you will study in your higher semester. For time being, just try to understand certain types of loads, they will be there on such kind of process, right? So with this understanding, let us try to solve this numerical. What we have seen, we are in a position to identify the reaction forces first of all. Secondly, this equation is getting satisfied. That means we will be in a position to calculate the member forces also. Now, how to calculate that? Let us assume first method, which is method of joints. Method of joints. So in method of joints, what is done? These joints, whatever are given, they are separated in such a way that these supports will carry or represent different members those are attached to it. Okay? So let's say before going for the separation, let us first of all find out the unknowns, external unknowns. Okay, first external unknowns. Since it is possible for us to find out the external reaction forces, let me call this as RAH, this to be RAV, RE. So external reactions. Very simple. Summation of force x direction equal to 0. Do you observe any kind of horizontal force over here in this complete figure? Other than RH, there is no other force. So RH will be equal to 0. Summation of forces in y direction equal to 0. How many forces? RAV minus 60 minus 40 minus 50 plus RE equal to 0. Am I right? Okay. Then summation of moment. Now you take moment about any point. Let's say summation of moment about A equal to 0. 40 into, can you please let me know what will be the perpendicular distance for 40? Yes? 1 meter. Why? Because this is 60 degree, right? 1 meter. Then it is moving in the clockwise direction. Another is 60 into 2, barabar? Then 50 into 3 and बराबर है क्या देख लो एक बार. ठीक है? Therefore RE, how much? How much do we get? Yes? 77.5. 77.5 kilonewton. Don't forget to mention the unit. And whatever units are given in the numerical, those are to be represented. Next, what about RAV? 72.5 kilonewton. Both are positive? Now we have identified the reaction forces at each joint, you can say. Now you apply the method of joints. Now the method of joint concept will come into picture. Method of joints. So as I've told you, You are supposed to isolate any of the joints, and you are supposed to identify the unknowns based on the free body diagram. Let me consider joint A. Okay. So at joint A, how many reactions are there? There are two reactions, out of which this is 0. Whereas RAV, it came out to be 72.5 kilonewton, isn't it? There are two members which are attached. Member AB and member AC. So initially, I will assume this force, that is tension force, in both the members. I don't know the nature of the force. So initially, I will assume tension at joint A. So what I have done, I have separated this joint and I have represented the free body diagram of that. You know the angle, this is 60 degree. Now, being an inclined member or inclined force, this can be resolved. Everything is in equilibrium, because of which we are in position to draw the free body diagram, and hence we are in a position to make use of equations of equilibrium. Summation of force in x direction equal to 0. How many forces do we have? So I will write down FAB cos of 60 plus FAC equal to 0. Am I right? Then summation of force in y direction equal to 0. How much it is? FAB sine 60 plus 72, 72.5. Any other vertical force equal to 0. From here, I can get the value for AFAB, force in member AB. कितना है? This represents minus 83.71. ठीक है? Kilo Newton. Minus, what does that represent? That my assumed direction of force is wrong. So instead of tension, now it is compression. Okay. So this again can be represented in the form like this: 83.71 kilonewton compression. बराबर है? ठीक है? Then what you do? You calculate another force in member AC. So force in member AC, how much does this come out to be? Substitute AB in this equation. 41.86 kilonewton, and this is positive. That means force in member AC will be tension. Okay, whatever we have assumed, that is correct. Next, this joint A is now complete. Fine. Then you choose such a joint where you will find that there are maximum number of knowns and minimum unknown. तो इसलिए मैंने देखो ये पहले joint A choose किया. I could have considered E also. There was no harm, but I have started with A. If I would have considered joint B initially, so over here, what would have been the number of unknowns? How many unknowns would have been there? BA, BC and BD. If I would have considered B instead of joint A, in that case, number of unknowns shall be 1, 2, 3. Okay, so selection of joint initially is very, very important. Now I can move to let's say joint B, joint B, and now I can draw the free body diagram of that joint B. So in that joint B, you will observe that there are these members which are connected. Out of this, you will observe that we have already evaluated the value of force in member AB, that is this member. This came out to be compression force. This came out to be compression force, isn't it? So you can represent the direction of the arrow accordingly. So compression is nothing but towards the joint. The arrow which is facing towards the joint, that will be a compression force. Okay. So this member force it came out to be 83.71. This you can resolve. Next, this force in member BC, I will represent it like this, force in member BC, and I will assume initially the direction to the compression, tension. Here also I will assume tension force. So force in member BD. This is an inclined force, so I can resolve this inclination into component. This is 60 degree. This is again 60 degree. Fine. I will write down F, rather, I have already calculated this value. So this is 83.71 cos 60, 83.71 sin 60, correct? This is FBC cos 60. This is FBC sin 60. Correct? Now make use of equations of equilibrium. Force in x direction equal to 0. How many forces are there? 83.71 cos 60 plus FBD plus FBC cos 60. All are acting in the positive direction. Okay, equal to 0. Done. Then from here you will get some equation in terms of FBD and FBC. Then summation of forces in y direction equal to 0. 83.71 sin 60 minus FBC sin 60 and nothing else. 1 minute, 1 minute. There is one more force. Yes, this is 40 kilonewton. Free body diagram should represent all the forces. So this is 40 kilonewton, which is acting in the negative y direction, equated to 0. You solve these two equations and you please find out the values for FBC and similarly FBD. Please find out. Hmm. 37.526. Okay. Okay, phi 3, let's say kilonewton.
And whether it is
Okay, and BD negative 60.62 kilonewton. ठीक है. That means BD, whatever we have considered, it is not tension, it is compression. So over here, this negative sign is representing the tension force. I mean, this, or we can say 60.62 kilonewton compression. ठीक है? Likewise, you can solve the other joints also. So I hope you have understood the process. What you can do, you can go for the next joint, let's say joint E. You show all the forces which are available on joint E, and accordingly you find out the unknown member forces. Then you go for joint C or joint D, whatever you feel like, and solve it. So can you complete this numerical? I hope this is understood. Okay. So I will stop over here. In the next class, we will see a few more numerical related to truss. Thank you.
Thank you, sir.